Before we get started, I want to once again take a moment to really thank our sponsors. For without them, this event would not be possible. And they've made it so that even though we couldn't all be in person at Fairmont again this year, that we can still gather at least in this format and get some good information out there and hopefully get together a little bit via either Zoom or either a telephone call or a conference call or something and get some networking done amongst ourselves. So a big thank you goes to our mother lode sponsors, which are the Forest Service, the BLM, and Montana DEQ. Those are our large main sponsors, as well as Montana Tech. Our platinum sponsor, which is Siboney Stillwater. Gold sponsors, CDM Smith, Hecla Mining Company, and Pioneer Technical Services. Silver sponsors, which are ERO Resources Corporation, Haley and Aldrich, Hydrometrics, Mall Foster and Alongi, Morrison Merrily, Rio Tinto, Sandfire Resources America, Spectrum Engineering and Environmental. And our copper sponsors, which are ACZ Labs, Arcadis, Energy Laboratories, Montgomery and Associates, SVL Analytics, and Water and Environmental Technologies. And you will see during breaks, lunchtime, various times throughout the conference, we will be running videos that have been supplied by these sponsors. So, take a look and see if there isn't something that you could learn about some of our wonderful sponsors. So, with that being said, another thing is I will, once again today, draw for some more Amazon gift cards. We will do that after lunch. And for the lucky winners, I will email you an Amazon e-card for you to use on whatever you would like. So we are going to get started with our first presenter of the day. Our first talk is from Neil Westison, and he is a partner at Crowley & Fleck, working in environmental litigation. He graduated from the University of Montana in 1988 and then the University of Colorado Law School in 1991. Neil recently relocated to Helena after living in Bozeman for the last 20 years. So I would like to welcome aboard Neil.
Morning. Thank you, Susie. Can you hear me okay?
Yes, you sound good.
Great. And people can see my PowerPoint?
Yes.
Awesome. Well, good morning, everyone. Thanks for joining in this interesting format. Sounds like it's gone pretty well. I met some of you last year in Fairmont, and this talk is similar to the one I gave there, only with some updated information. So there is some thunderstorm activity in Helena, so if I stop talking, it's because being drowned out by the thunderstorm. This title of my program is No Good Deed Goes Unpunished. It's the story of the Sunnyside Gold Corporation, which is a client I've been working with for a number of years down in southwestern Colorado. Sorry, I gotta get this working. There we go. Again, my name's Neil Westison. I'm a partner at our firm. Pam Garman, an associate in our office in Billings, helped put this program together as well. A little bit of background on the Sunnyside Gold Corporation. Sunnyside was formed in 1985, acquired the Sunnyside mine out of the Standard Metals bankruptcy. There were a number of properties that were available. Sunnyside brought the mine back into environmental compliance, mined for only about 5 years, 1986 to 1991, and unfortunately, despite everyone's best intentions and hopes, the mine was never profitable. This was a money-losing operation from the beginning. The mine is located about 8 miles north of Silverton, Colorado. It's a naturally mineralized area, similar to Helena, Butte, just minerals there for millions of years. It's been naturally discharging heavy metals for again, thousands of years. Acid rock drainage, poor water quality were prevalent long before the advent of mining. Some of the creeks in the area are named Cement Creek, Mineral Creek. Never did support a historic fishery just based on the natural geology. The loading there is limited aquatic life. There are limited trout populations around the Silverton area just because of that natural geology. Serious mining began in the early 1870s. Gold, silver, lead, copper were the main metals mined. This area was a boom town, a boom area, 1,500 mines, 50 mill sites, 8 active smelters, 35 aerial tramways. At this time, historic practice was you mine and you just discharge whatever is generated right into the river, any of the waste materials. So about 8.6 million short tons of tailings discharged directly into the streams. In the 1970s, as everyone's aware, regulations that were established to monitor and limit discharges and to require reclamation. And so by the time Sunnyside comes on the scene in 1985, we're under the modern era of environmental regulation. This just gives you a historic picture of what these early mining days were like. Not exactly a MSHA approved mode of commute to your mine site, but this is what people were willing to put up with. And some of these aerial tramways that were built, it's kind of remarkable in this, most of the areas above 10, 12, 13,000 feet. Sunnyside closed in 1991. The economics just didn't justify the mine anymore. And so this was their approach was reclaim and restore the surface in the Sunnyside Basin. They were going to reclaim and restore the surface at the American Tunnel portal. That's where it was the main drainage area and haulage tunnel. Most of their tailings were stored at a Mayflower tailings impoundment, so they needed to stabilize that area. Control and minimize discharge by installing bulkheads. And then this was a little bit unique for the time and maybe still is, but they were going to remediate a number of sites that they didn't own in the basin to provide some offset metal load reduction for any residual discharges from their facilities. And ultimately, the success of their reclamation efforts would be determined by measuring zinc concentrations at a gauging station on the Animas River downstream of the confluence of Cement Creek, Mineral Creek, and the Animas. So that was the plan in 1991. This plan was set out actually in their reclamation permits, even as they began mining. It was ultimately put into a consent decree with the state of Colorado and approved by a court. EPA was not a signatory to the consent decree, but they reviewed the plan that was put together, provided comments, and ultimately endorsed the approach. The experts reviewed the proposal for bulkheads and concluded this was an ideal location for that type of approach based on the geology and the ability to restore the hydrogeology with bulkheads. EPA applauded the parties and this kind of new basin-wide approach to water quality, not just site-specific, but basin-wide. So that was the plan. It was reviewed, it was approved, it was published, it was commented on, and Sunnyside went to work. A lot of before and after pictures showing some really successful reclamation. Sunnyside Basin in 1988, and then the basin in 1996. They placed about 240,000 cubic yards of fill. There had been a subsidence in 1978 where Lake Emma actually collapsed into the mine. They fixed that, restored the drainage, contoured it around that subsidence, and so you get a good before and after that shows the efforts that they went to. Again, at the American Tunnel, that was their discharge point before and after, a lot of reclamation work, 80,000 tons of historic mine waste and tailings removed. The Mayflower impoundment, this is where the waste from the mill was placed, again, revegetated, recontoured, and drainage away from local rivers. Again, there are 4 Mayflower impoundments. This is impoundment number 2. This is not an easy place to get this kind of vegetation to grow at this high altitude. Very successful efforts on Sunnyside's part. I mentioned the bulkheads. That was a big part of Sunnyside's reclamation plan. The intent was to restore natural hydrology. If there was before mining, the mountains would have been full of infiltrated groundwater. After mining, that water comes out the adits. If you put in a bulkhead, the water is back to where it would have been before mining. So SGC installed a series of 9 bulkheads in the Sunnyside mine and the American Tunnel and the Terry Tunnel. Those bulkheads, they're massive. They were engineered, over-engineered, over-designed with factors of safety, and they isolate the interior workings of the mine and prevent water flow from the interior workings directly to the surface through those adits. As expected, installing bulkheads did cause the water table to return towards natural levels. So you had some seeps, springs, and other flows increasing. That was, again, the goal. That's what it was like pre-mining. Sunnyside also injected thousands of tons of lime into the mine pool to try and speed up the neutralization process. All of the bulkheads Sunnyside installed are stable. They're still performing as intended, and they've served their purpose. They've isolated the interior workings of the mine. Again, what was somewhat unique about this is the region-wide approach to reclamation. Sunnyside would be released of its reclamation obligations, both in exchange for bulkheading, the mine drainage, but also for completing other reclamation projects in the region. So they installed 9 bulkheads on property they owned and property that they didn't own. They also removed mine waste and historic tailings from other properties and put it on the Mayflower impoundments, and then again recontoured and reseeded areas to improve stability and vegetation. So this is a picture of the lead carbonate tailings. This is an area Sunnyside never owned or operated, but reclaimed as part of their consent decree and reclamation obligations. And again, it's sort of risky to touch a property you don't own with CERCLA, but that's the decision that was made and the efforts that they undertook. So that's where things stood. They spent, and this number has grown, $30 million on reclamation and remediation. For their efforts, they won an award early on from the Mineland Reclamation Division and the Department of Natural Resources in Colorado for just bringing the site back into compliance from the way it was left following the Standard Metals bankruptcy. And then again, as part of their closure activities, they won that Mineland Reclamation Award in 1994. They ended up fulfilling all their regulatory requirements, complied with their reclamation obligations. The consent decree was released in 2003, and things seem to be in a fairly stable status. That's how it was in 2015. The bulkheads had been in place, functioning as designed for many years. State of Colorado and EPA were doing work on other sites in the area, installing additional bulkheads to further restore that natural hydrology. I've heard it described as a whack-a-mole approach. As water comes out one adit, you bulkhead that one. As it moves to another adit, you bulkhead that one, and slowly you put the mountain back to the way it was before mining. So EPA in Colorado put a bulkhead in at the Red and Bonita mine. They did not close it. They just closed it for the first time this summer. And they were contemplating an additional bulkhead at the Gold King mine, the nearby Gold King mine. And bulkheads, the purpose is you fill these mines with water, you submerge the metals in water, you reduce the oxygen availability, and then you reduce ultimately the generation of acid rock drainage and thereby improve water quality. That's the whole point. EPA and its contractors are working in 2015. They excavate into the exterior of the Gold King mine, and they end up releasing about 3 million gallons of impounded water. That water washes away a BLM-owned waste pile. It turns the Animas River bright orange. People will remember that kind of slug of tan-colored water makes its way downstream for several days and eventually, weeks later, settles out in Lake Powell. I think this video will play and you can see really what happened on the day of the event. Whoops. I'm going to go back and try that again. See, this is as EPA's excavating into the exterior, then drainage starts coming out.
Really high. Is he gonna go close it up?
The suggestion that they close it up, you'll see, was not followed.
What are we doing now? Get a little video of this, I suppose. We were back 20 feet out.
That's the BLM waste pile downstream that ends up being washed away. It's saying that's all the water coming from the Gold Key mine. The volume is estimated at about 3 million gallons, and it comes out very quickly. This is a famous picture that was taken of kayakers in the Animas River. You can see that's what ended up happening to the river. The color that it turned generated national and international media coverage. Here you can kind of see, that's what the river used to look like. And then this is the slug of orange water making its way downstream. Ultimately, there was no impact to the fishery. That was good news. The river returned to pre-blowout conditions within about a week. The New Mexico Environmental Department has found no long-term damage to the environment. State of Utah, their environmental folks reached the same conclusion. I mean, it looked bad, but it actually didn't cause much, if any, damage to the environment. EPA admitted responsibility for the blowout. The administrator at the time said that EPA accepted responsibility. EPA is taking responsibility to ensure that it is cleaned up. And their website, even today, the EPA's website on the Gold King blowout, reads that EPA takes responsibility for the release and is committed to working hand in hand with the government, states, and tribes. And so that was the status right after the blowout. And what follows has been a lot of litigation, and I guess cynically speaking, when the deepest pocket in the world, the United States government, admits responsibility for something like this, you get lawsuits. So New Mexico filed suit against the EPA, government contractors, and Sunnyside Gold, seeking about $160 million. The Navajo tribe filed suit seeking about $120 million. 300 individual members of the tribe filed suit seeking about 70 million. Of those 300, probably 70 have now abandoned their claims. Their lawyers are seeking to withdraw from representing them. It just seems like they were fired up in 2015 and they've lost interest at this point. And then Utah filed suit, the biggest claim of all, seeking $1.9 billion. And the theory there was we may have to dredge Lake Powell to get all of these metals out from the bottom of the lake. And that's how they came up with that number. I'm not sure anybody ever thought that was a good idea given what else is buried under Lake Powell, but that was how Utah generated a large initial claim. EPA's got a unique role here. I mean, they've said we caused the blowout and they've accepted responsibility for it. After the blowout, they created a Superfund site, listed the whole 100,000 acres as a site in 2016, but they never did score the Sunnyside mine or SGC's Sunnyside Gold's property. EPA is the lead agency administering this site. They're also obviously a defendant in the underlying litigation. They've been sued. They're also a PRP, both for their role in causing the Gold King blowout and also because the vast majority of the land in that 100,000 acre Superfund site is owned by the federal government. Mountain States Legal Foundation filed a complaint with the Office of Inspector General saying, EPA is in too conflicted of a position to run this site. Somebody else ought to. That complaint went nowhere. No response filed. So it is just kind of unique to have EPA on almost both sides of a verdict form, both sides of a single event. The theory against Sunnyside is that the state approved and state court blessed consent decree work, including the bulkheads, created the conditions by which the blowout was possible. It's like if you hadn't put any bulkheads in, the water would have kept coming out the American Tunnel forever, and then it wouldn't have been in the Gold King mine, and so it wouldn't have been there for us to blow it out. That's the theory. The other theory is that even though Sunnyside had permits for its discharges and all of the discharges were permitted, that they're still subject to jurisdiction in downstream states. So they've been sued in New Mexico and in Utah. So I guess the analogy is if you've got a permitted discharge in Montana, you could be sued in Louisiana because the water may all eventually get there down the Mississippi. The EPA's theory is also that because Sunnyside is an owner and operator of the Sunnyside mine, they're a PRP responsible for cleanup of the entire Superfund site. And at the time I wrote this, it was $55 million the EPA had spent. Recently, they reached a settlement with the state of Utah, and the press releases said they'd spent $75 million. So that exposure is now up to $75 million to clean up the work or the situation at the Gold King mine and a few other sites. Not surprisingly, again, cynically, this has generated lots and lots of work for lawyers. The EPA Region 8 head announced that EPA has 44 battle-tested lawyers ready to litigate these matters, and I can tell you that more are being added every day. We have depositions with 20 to 25 lawyers, and there's just a lot of attorneys and experts spending time on this matter. Every plaintiff, every defendant has multiple lawyers, multiple experts. The blowout happened back in 2015. Our most recent scheduling order says that phase 1 of the dispute is to be ready for trial in January of 2022. Ready for trial doesn't mean tried. Given the other cases on the docket in New Mexico, it probably wouldn't be tried until 2023, 8 years after the blowout. That's just phase 1. There's to be a phase 2, phase 3, and then possibly 3 separate trials in Utah down the road. So that process alone will take years and will cost millions and millions of dollars. So Sunnyside Gold's legacy, they acquired an abandoned mine out of bankruptcy, brought it into environmental compliance. They operated the mine for 5 years under permits and regulation, never at a profit. They closed and reclaimed the mine in accordance with the regulators overseeing their conduct, the blessings of a Colorado court. They also reclaimed property they never owned or operated. And as a result of their efforts, water quality in the region was improved. They've extensively studied the water quality data. Steve Lang, an expert with Knight Piesold, wrote a report that Sunnyside's extensive reclamation substantially reduced metals loading to the Annis River. So they were not a bad actor, but a net positive for the environment. Their reward for those efforts, they're now a defendant in multiple lawsuits. They'll spend years and millions of dollars on lawyers and experts to defend themselves. They're now also subject to CERCLA exposure, but for the blowout and the events of 2015, it's unlikely this area ever gets listed on the national priorities list. There had been a lot of environmental remediation work going on for decades without a Superfund listing, and now it's on the list, and the entire 100,000 acre region is a Superfund site. So the conclusion, at this point is no good deed goes unpunished. The only other update I would add is there was recently a settlement between EPA and the state of Utah. Some creative press reports about that suggested that it was a $360 million settlement. That is not true. EPA agreed to do ongoing work in Bonita Peak in Colorado, and then some additional work in Utah. The total of all of that potential work might reach that $360 million figure. No check was written to Utah. Utah has the right to apply for 2 grants from EPA under, I think, 319 grants for about a total of $3 million. And then I think all of their previously incurred costs for responding to the blowout were already reimbursed. So Utah preserved its claims against Sunnyside, and so those claims are ongoing, but their claims with EPA and EPA's contractors have been resolved. Otherwise, the parties are just proceeding towards litigation and taking depositions and spending money that could probably be put to better use cleaning up the environment. So that's the update and my remarks, and I'm happy to answer any questions if people can hear me and have any.
Any questions for Neil? Yes, if you have a question, please type it into the group chat.
Yeah, and if folks want to unmute and just ask it, it's fine too.
Oh, yeah. That's a good idea. There's a question. Is there a projected lifespan for the various SGC bulkheads?
Good question. Yeah, in excess of 100 years. They're concrete, but they also had, and I'm not an engineer, but fly ash added to try to increase the corrosion resistance of the structures. And so I think nobody, I think, put a definitive date on it of, this is the date they no longer work, but the anticipated lifespan is in excess of 100 years. And the other point I'd make is when they do, or if they ever do fail, the failure of these is not a blowout. It's not a catastrophic failure. It would just be, they would start leaking. And so it's not the kind of thing that happened at the Gold King. It would just be some increased flows coming out of probably the American tunnel.
And we have another question. Explain more what you mean by scoring Sunnyside Gold Mine, please.
Yeah, good question. To put a site to make an area listed as a Superfund site, it's supposed to be scored under the hazard ranking system. It's the HRS system. And EPA has a number of factors of what are the metals there and how dangerous are they, where might they go. And they went, and there are 48 different sites within the Bonita Peak area that they reviewed and included, and they scored a number of them. This is the discharge from this mine, this is what comes out, this is how hazardous it is. It meets I think it's 28.5 is the minimum to be listed. They never did score the Sunnyside mine or any discharges from the mine, nor the Mayflower impoundments. Those were listed as study areas, but not actually scored. We questioned that and argued that was improper. That went to the DC Circuit Court of Appeals, and the Court of Appeals rejected our challenge and said they don't have to score each mine. They can just score the 100,000 acres as a whole, and the term they used was the commingled release from all of these different mines is enough to justify a listing, and so they upheld the listing. Good question.
Another question is, was there any similar litigation after the Lake Emma blowout?
No, there was not. And I again, good question. There was litigation following that, but I think it was between the Standard Metals, the owner of the mine, and their insurance companies to try and recoup any damages that they had. But again, that happened in 1978, and no claims by New Mexico or Utah or the Navajo Nation or anyone else that their water quality had been harmed. To be fair, I think the coverage of the Lake Emma blowout was probably restricted to the Silverton Standard and the Durango Herald, as opposed to the national media coverage that the Gold King blowout generated.
Great. Anything else for Neil? Okay, well, thank you very much, Neil. That was an excellent presentation.
Thank you.
Appreciate it.
Thanks,
And if
everybody.
anyone would like to reach out to Neil, you know, if you have additional questions, please feel free to email Neil directly. His email is on the list of attendees.
For sure.
Thank you.
Right. Thank you.
Next, I did want to make one other announcement before we go on to our next speaker. I mentioned this earlier, but all of these presentations will be recorded and posted to a YouTube channel after the conference is over. So for anyone who would like to go back and reference these, or if you happen to miss one throughout the day, you can go back and watch it at a later date. And I will send out notifications once those videos are posted. So our next presenter is Gianna Damiano from, what's that? Could you, Gianna, can you flip your PowerPoint display settings?
Is that better?
Is that better, Dan? Could you try it again? Because okay, well, while we're waiting for the PowerPoint to get sorted out, I will introduce Gianna. Gianna Damiano is an engineer with Mall, Foster, and Alonji in the North Idaho offices. Since her career began in 2016, she has been involved with projects on the Bunker Hill Superfund site in the Silver Valley. Through her experience as the oversight officer and client representative and now project manager for stormwater management related projects on the site, she has garnered a unique perspective on using engineering principles to benefit communities. Today, she will be speaking on this intersection of communities and remediation efforts at the Bunker Hill. So welcome, Gianna.
Thank you, Susie. Is it all sorted out now?
Yes, it looks good.
Perfect. So good morning, everyone, and thank you for the opportunity to speak to you today about projects that I've been closely involved with for the last 4 years. As Susie mentioned, my name is Gianna Damiano. I work in the Kellogg and Coeur d'Alene offices for Mall, Foster, and Alonji, and have been working for the last 4 summers up to last year on projects within the Bunker Hill Superfund site called Remedy Protection, which is what I want to talk about today. And it might be a slightly different perspective on mine remediation and its effect on communities than we've heard before. So today I want to go over 3 main areas, and those areas are the background and history of the Silver Valley, just to give us kind of some setting. for these projects, a little brief history of the Bunker Hill Mining and Metallurgical Superfund site, as well as some structure of the Coeur d'Alene Custodial and Work Trust, and then to dive into remedy protection, what that program is, its purpose and objectives, and a few project examples. So the Silver Valley in North Idaho generally spans from the town of Cataldo to the Montana-Idaho border. Up here in the left-hand corner, you can see, let me turn this on, you can see in this orange box here, this is the general location of the valley. If you ever drive through Idaho on I-90, you would drive through the Silver Valley. So it was once home to over 815 mine prospects. And mining began in earnest in the 1880s after Noah Kellogg, or more accurately his donkey, discovered silver near what is known today as the town of Kellogg, as in addition to Andrew Pritchard striking gold on the North Fork of the Coeur d'Alene River. The area boomed with the influx of industry and produced more than 1.2 billion ounces of silver, 3 million tons of zinc, 8 million tons of lead, as well as quantities of gold and copper during its peak mining years. And the Silver Valley was once considered to be one of the most prolific silver districts in the world. And here on this slide, we have this bottom photo is a photo of the Hecla Star mine near Burke, Idaho, looking south. This mine was famous for the railroad that came through and the valley being so narrow that some shop owners had to roll up their shop awnings in order to let the train pass. And then this top photo just shows an example of a mine in the area. So in the 1980s, silver dropped to a price of $3 an ounce, which put many of the mining companies underwater. The remaining companies moved on to other ventures elsewhere, leaving the valley in an economic depression and leaving behind years of heavy metals contaminations that was just beginning to be understood by the EPA. In 1983, the Bunker Hill Mining and Metallurgical Superfund site was established by EPA, who began remediation projects with settlement funds back in the 80s and 90s. And here on this slide, we have two examples, kind of the setting here, which shows the mountainous terrain, the narrow valleys, the short construction seasons that we have due to lots of snow, lots of spring runoff. And speaking of runoff and flooding, here we have a picture of the Wallace flood that kind of shows and demonstrates the need to protect the area from flooding and what remedy was installed. So the Bunker Hill is the second largest Superfund site in the country. It spans 2 counties, Shoshone and Kootenai in Idaho, and it spans all 166 miles of the flood-prone Coeur d'Alene River. Remediation projects within the Bunker Hill in the 80s and 90s began and focused in what is called the box, outlined in red on this slide. And it generally spans from Kingston, Idaho to Kellogg, Idaho. And in 2010, the Coeur d'Alene Custodial and Work Trust was established through the settlement agreement between EPA and a Sarco mining company to manage and implement projects outside of the box. So here we have Montana over here on the Montana-Idaho border. Right along here you have I-90 that follows the South Fork of the Coeur d'Alene River and then departs into Coeur d'Alene. Kellogg is right here And the Coeur d'Alene Trust and the project I'll be talking about today are in this upper basin, and we're beginning work down in the lower basin. But the main focus over the last few years has been in this upper basin. So a little background on the Coeur d'Alene Trust. The Coeur d'Alene Trust is comprised of a trustee who fiscally manages the settlement funds and 3 local program managers. And the projects and programs managed by the trust range in variety from the construction of waste repositories, which we learned a little bit about yesterday, to source site remediations. Here we have, we're showing the approximate breakdown of total anticipated costs, which include both incurred costs to date and estimated future costs for each program that the trust manages, and this metric is updated annually. And right here in purple is what we'll be discussing today. So the program that I want to focus on and dive a little bit into today is called the Remedy Protection Program. It is a program that was implemented to protect the selected remedy from erosion or recontamination caused by contaminated stormwaters. So what is this remedy that I keep mentioning? This remedy that's being protected is the 5.9 million square feet of clean soil caps that act as protective barriers between contaminants of concern, which among the list include lead and arsenic and receptors in mostly residential areas. The problem with new soil caps is that they can be susceptible to erosion and recontamination by stormwater and tributary flood events, which can then lead to an increase in receptor exposure to those contaminants of concern. And many of the communities in surrounding rural gulches in the Silver Valley are prone to flooding and lack adequate stormwater infrastructure and channel capacity to route those flood flows away from the remedy. The solution, so here we have an example of a stormwater ditch actually after one of the remedy protection projects. Since the first project was implemented in 2012 for the program, 122 acres of remedy has been protected through a total of 19 projects in 4 communities, as well as in the surrounding side gulches. And when I say side gulches, these are unincorporated communities in the drainage basins outside of the main cities. The 4 main communities worked in are Wallace, Osborne, Silverton, and Mullen. Mullen is your furthest east, next to the Montana-Idaho border, with Osborne being your furthest west. And the total cost and scope of these projects totaled nearly $20 million invested in infrastructure in the area. As of March of this year, the program was finalized and closed by EPA after addressing all identified projects within the record of decision amendment. For our remaining time today, I'll go through a few project examples. So the first project example I'd like to highlight is the Star parking area. I mentioned the Hecla Star mine earlier. And this photo shows what remains of that structure, just looking north instead of south as we looked in that historic photo. And as you can see, our project alignment started at the north side of this building and ran to the southern edge of this compound, and was needed because of the high flows and spring flows off of these hills, as well as the county used this, what was previously a gravel storage area or parking area for snow removal activities, causing high amounts of overland flow and sheet flow in the spring to erode away downstream residents' caps. And here we installed a couple inlet structures, 900 feet approximately storm drain pipe, 3 catch basins, and a couple manholes, as well as surface restoration items that range from riprap to topsoil with seed and asphalt. And this was a project example of one of our side gulch projects, not in an incorporated city. The next project, we'll move to Mullen, Idaho, on the Mill Creek project. Mill Creek was a channel capacity and conveyance project along the flood-prone tributary of Mill Creek in Mullen, Idaho. The channel was undersized to carry capacities modeled in the design storm, posing flood damage and ecological risks to the houses and remedies along its alignment. The old channel also posed safety risks to the community as portions of the channel flowed through an old box culvert that caved in a yard that had children living in that house at the time, as well as the channel ran through a house basement at one point and under walkways that just had planks covering it. Here on this slide, we see a before picture on your right and an after picture on your left. And as you can clearly see, there was a dramatic increase in channel capacity for this creek. And you can see a little bit, you can see a house here in this upper left-hand corner. There are 2 other houses over here and more houses on this west side of the creek. And so demonstrating that this creek really ran through people's yards and near their porches and other things. The project began in 2016 and ended in 2017, was a multiple phase project. And this lower portion that this was phase 1 we see here was entirely channel capacity improvements, whereas the next year's phase, what we call Upper Mill Creek, was a combination of both channel improvements and pipe installation. The pipe was installed due to the limiting factors of the creek running through houses and not being able to fit a channel in between the house and the narrow valley walls. And so here we see in the top third of the project, some channel improvements where we had enough room going into an inlet structure into our pipe, and then pipe installation, which was 48-inch CHDPE pipe. And here in this upper right-hand photo, you can barely see the tip of the outfall into open channel flow. The Mill Creek project, just for kind of scale, was a $2 million project and multi-year, as described earlier. Our third project example kind of switches back over to our side gulch projects and takes us across the valley west to Kingston, Idaho, which is, as you're traveling on I-90, about 10 to 15 minutes away from Kellogg, west towards Coeur d'Alene. And the Hunt Gulch project I wanted to highlight because it was actually our smallest project completed. It was about $100,000 project and included only 400 feet of pipe, 3 catch basins, some culvert replacements, and some erosion control on the ditches, as you can see in the top left-hand corner, the ditches ran full a good portion of the spring runoff period. And though the community that we were working in was fairly small, it had a large drainage basin north of it that came down off the hill and all discharged down this road. And most of the culverts and previous infrastructure had been long clogged, causing overland and sheet flow just down this road in the spring. So my final project example for today moves back up to Mullen, Idaho, to another two-phase multi-year project. This project is called the Tiger Creek Project and is actually on the opposite side of Mullen from the Mill Creek project described earlier. And it was a combination of both flood conveyance flow project and storm flow. And these photos kind of depict our setting up in Tiger Creek and some of our more interesting working conditions. Here on the left, we see the mountainous rural community. This is the first phase of the project. And one thing I'll note here is on this hill we see in the background, you always knew when you had to wrap up a project in Mullen by watching the snow level come down on this hill. And as the locals will always say, always told me that they get a good amount of snow up in Mullen. So which kind of is our limiting factor on getting pavement on the ground. And then this right-hand photo shows some of the really tight corridors we're working in. We're working in between, there's a house there, a house here, with a pipe alignment going through. And where I'm standing in this photo is quite the slope to get from up here down to where the excavator is currently sitting. Pipe runs on the Tiger Creek project were designed to fit the capacity of both Tiger Creek and road stormwater runoff. It involved on phase one, the installation of 36-inch diameter RCP pipe, as you can see being installed in the top photo, due to concerns for high groundwater and possibilities of float. And for phase two, the installation of 24-inch PP pipe. And phase two was by far the most logistically challenging of the projects I have had the opportunity to directly oversee. Pipe runs and surface grades in places were upwards of 20% in these narrow road corridors with lots of overhead wires. You can just barely see the network of overhead wires along here, in addition to lots of pre-existing utilities in the ground and trying to fit our pipe in those corridors. And then, as mentioned earlier, the working in between houses. And though it was the most challenging, it was one of our most successful projects. It began in 2018 and was completed in 2019 for approximately $2 million. So it's just some other items to note that are unique to the Remedy Protection Project as compared to other programs implemented by the Trust or many other remediation projects. I'll note that this was for the most part, a post-residential cleanup. A majority of the caps were already installed prior to us going in and protecting them via these projects. It was also a very collaborative process with local municipalities, and the trust who executed the projects, as well as having a collaborative team within the trust design and oversight team. For effectiveness, every spring we go and look at these projects, and so far they have all functioned as they were designed to. We haven't seen any major flooding events that have overtopped our pipes or our channels, and we will continue to monitor the effectiveness moving forward, especially for those projects that were most recently completed. And a really interesting aspect of the remedy protection projects is that the operations and maintenance is actually a collaborative process, and it is not the responsibility of the Coeur d'Alene Trust, but O&M is actually handed over and signed over to the local municipality immediately upon closure of the project. So for instance, for the Mill Creek and Tiger Creek projects, O&M is with the city of Mullen, and for the side gulches, the operations and maintenance goes to the counties. So that was a quick overview of remedy protection, and as a program and some project examples. I'd love to take some questions.
Any questions for Gianna? Okay, well, thank you very much, Gianna. That was very informative. At this point, we will go on break until 10:30. And so thank you all for coming on board this morning. We'll see you back here in roughly a half hour, and enjoy some free time, or enjoy the sponsor videos that we'll have playing during the break. Thank you.
Everywhere we're operating, we're the largest private employer there. People are engaged with the mines, and they take ownership of the mines. And as a result, the company is committed to the community.
Before we begin, we think of the end. During the operation, how do we minimize our impact and protect the environment? And then ultimately, how do we restore and reclaim that land to other productive uses?
We have a responsibility to our workers that they can stay safe. We have a responsibility to the communities that the workers will return home for dinner at night. We have a responsibility to our shareholders. We have a responsibility to governments that we will make a profit and we will pay taxes in order to support the general infrastructure. We invest in the communities.
It's that we operate in the best jurisdictions in the world, in Mexico, Canada, and the United States. And today that's more important in a precious metals company than almost anything else in the world.
The company that has the right culture, they're going to do it responsibly all over the world. And in the United States, though, you have the best environment to do it the best, right? You've got great laws, you've got great workforce, you have great minerals.
We have a plan, we have the team, we have the skill set, we've got the operators. And when you operate well in a community, it shows in the happiness of the workers and the happiness of the community.
Instead of saying, that's not my job, you say, what can I do to help?
So I'd rather it be done here where we can do it responsibly, and you have a company like Hecla that does it, that cares, because we need these resources.
I'm Phil Baker, CEO of Hecla Mining, and we're responsible,
safe,
Responsible, safe, and innovative.
Mall Foster and Alongi is an integrated multidisciplinary firm consulting in environmental services, engineering, planning and development, GIS and data analysis, communications, and health and safety. We are passionate about working with clients to provide solutions for complicated sites throughout the Pacific Northwest. MFA has worked with the Coeur d'Alene Trust on remediation of the Bunker Hill Mining and Metallurgical Superfund site since 2010. MFA assists in program management and strategy, tracks documents and data, conducts site characterization and monitoring, and evaluates remedial action designs.
At CDM Smith, we are committed to making a difference for our clients, our people, our communities, and our world. Since 1947, we have been solving the most complex environmental and infrastructure challenges. Whether it's making every precious drop of water count through safe supplies, reliable conveyance and sustainable reuse, designing remediation systems and restoring ecosystems, or leveraging emerging technologies and multimodal strategies to connect people, places, and goods. We've been giving back. We are global citizens committed to helping communities, our own and those in need around the world. And perhaps most importantly, we've been making the world a bit better along the way. We're CDM Smith, and we can't wait to work with you.
Energy Laboratories, established in 1952, has been committed to analytical excellence ever since. We're committed to providing exceptional customer service experience with dedicated project managers available for assistance at any time, from the first contact with us through the final report being in your hands and any questions you may have after that. We're a full-service analytical laboratory specializing in water, soils, and organic analysis, and now offering such specialties as radiochemistry analysis, aquatic toxicity, and PFAS/PFOA. We work with a broad range of partners in industries such as municipalities, drinking water and waste treatment, through mine exploration and reclamation, monitoring wells, stormwater, waste characterization, petroleum production and exploration, and with agencies from federal agencies to industry and manufacturing, all the way to individuals interested in their private well or garden soils, and working with clients all the way from Alaska to Mississippi. We provide sampling supplies and sample containers, preservatives, paperwork available for local pickup or shipped directly to your location. We provide convenient prepaid return shipping labels to get your samples back to us as effortlessly as possible. With 4 locations to serve you across Montana and Wyoming, give us a call today to set up your next project. More information can be found at energylab.com.
So I'm Eric Mears. I'm with Haley & Aldrich. I'm the market segment leader for our mining practice. I've been in the mining industry or working with the mining industry now for about 25 years. We work for construction materials clients, we work for industrial minerals clients, and we also work for hard rock clients, which are the base and precious metals. Well, the material at this site ends up in a lot of different places: roads and highways and infrastructure and houses and sidewalks and schools. Materials that are mined here are really the building blocks of our society. And without sand and gravel mining, you don't have the modern society that we have today. We look for solutions that fix kind of the bigger picture. We're not just out there putting a hammer on a nail head. We're out there saying, okay, who are the stakeholders? What are the issues involved? What are the kind of interchangeable pieces here? Things that make a difference when you're trying to build a solution that meets multiple needs. We have our core practitioners, the people that have had their boots on the ground on mining sites, have often worked in the mining industry. We've got one profit and loss center, which doesn't silo our resources and our people. We don't compete against each other to solve our clients' problems. We can take diverse experience in different industries and apply them to deliver some innovative solutions for our mining clients. We ask a lot of questions. We ask questions about, okay, what are the things that are immediately right in front of us? What do we need to fix right now? Who are the stakeholders involved? What are the other pieces of the puzzle? The idea is that we come to the table once we've done a lot of listening with solutions that really fit our clients' needs.
Everywhere we're operating, we're the largest private employer there. People are engaged with the mines and they take ownership of the mines. And as a result, the company is committed to the community.
Before we begin, we think of the end. During the operation, how do we minimize our impact and protect the environment? And then ultimately, how do we restore and reclaim that land to other productive uses?
We have a responsibility to our workers that they can stay safe. We have a responsibility to the communities that the workers will return home for dinner at night. We have a responsibility to our shareholders. We have a responsibility to governments that we will make a profit and we will pay taxes in order to support the general infrastructure. We invest in the communities.
It's that we operate in the best jurisdictions in the world, in Mexico, Canada, and the United States. And today that's more important in a precious metals company than almost anything else in the world.
The company that has the right culture, they're going to do it responsibly all over the world. And in the United States, though, you have the best environment to do it the best, right? You've got great laws, you've got great workforce, you have great minerals.
We have a plan, we have the team, we have the skill set, we've got the operators. And when you operate well in a community, it shows in the happiness of the workers and the happiness of the community.
Instead of saying, that's not my job, you say, what can I do to help?
So I'd rather it be done here where we can do it responsibly and you have a company like Hecla that does it, that cares, because we need these resources.
I'm Phil Baker, CEO of Hecla Mining, and we're responsible,
safe,
Responsible, safe, and innovative.
Mal Foster and Alonji is an integrated multidisciplinary firm consulting in environmental services, engineering, planning and development, GIS and data analysis, communications, and health and safety. We are passionate about working with clients to provide solutions for complicated sites throughout the Pacific Northwest. MFA has worked with the Coeur d'Alene Trust on remediation of the Bunker Hill Mining and Metallurgical Superfund site since 2010. MFA assists in program management and strategy, tracks documents and data, conducts site characterization and monitoring, and evaluates remedial action designs.
Welcome to SVL Analytical. We've worked with thousands of clients from around the US and the world. We prioritize data integrity, quality lab practices, and personalized service with every analysis. At SVL, our team of professionals genuinely care about the relationships with our clients and take pride in the work we do, making SVL Analytical a trusted partner in environmental laboratory testing for nearly 50 years. Our clients' analytical testing results are used around the world to make critical, timely decisions. When you need streamlined and accurate results with a customer-centric approach, SVL is ready.
Hi, I'm Tim Van Weingarten, Vice President of Business Development at ACZ Laboratories. I've worked at ACZ for the last 30 years. ACZ has been a proud sponsor of Montana Tech's Mine Design Operations and Closure Conference for the past 25 years. ACZ was founded in 1980 as a support service to the mining industry. We support all aspects of the mine life cycle, from baseline water quality monitoring through operations permitting to closure, with our in-house static and kinetic testing capabilities that include ABA and humidity cell testing. ACZ provides litigation quality data with inorganic, organic, and radiochemical testing capabilities all in one location, something that large chain labs can't provide. Experience matters. ACZ's PM and client service staff have over 110 years of combined experience with ACZ. Please contact us at sales@acz.com or 1-800-334-5493 for a quote on your next project. Enjoy the conference.
From climate change and rising sea levels to rapid urbanization and pressure on natural resources, our world is a more complex place. Arcadis helps you navigate this complexity by understanding the bigger picture. Whether it is maximizing space in cities, making wasteland habitable, or simply taking what you do further, we deliver exceptional and sustainable outcomes safely and consistently. Connecting your vision to our know-how. Our people work collaboratively to create value through built and natural assets that work in harmony with their surroundings. From shopping centers in Shanghai or clean water in Sao Paulo, to new rail systems in Doha and reducing air pollution in Los Angeles. Our global operations and diverse experience mean we apply collective wisdom to every challenge, big and small. In this way, our experience protecting the Dutch coast for generations is applied to securing New York's flood defenses today. So, whatever your challenge, our teams bring the necessary perspective to provide the right answers now and in the future. Arcadis, improving quality of life.
At CDM Smith, we are committed to making a difference for our clients, our people, our communities, and our world. Since 1947, we have been solving the most complex environmental and infrastructure challenges. Whether it's making every precious drop of water count through safe supplies, reliable conveyance and sustainable reuse, designing remediation systems and restoring ecosystems, or leveraging emerging technologies and multimodal strategies to connect people, places, and goods. We've been giving back. We are global citizens committed to helping communities. our own, and those in need around the world. And perhaps most importantly, we've been making the world a bit better along the way. We're CDM Smith, and we can't wait to work with you.
Energy Laboratories, established in 1952, has been committed to analytical excellence ever since. We're committed to providing exceptional customer service experience with dedicated project managers available for assistance at any time, from the first contact with us through the final report being in your hands, and any questions you may have after that. We're a full-service analytical laboratory specializing in water, soils, and organic analysis, and now offering such specialties as radiochemistry analysis, aquatic toxicity, and PFAS/PFOA. We work with a broad range of partners in industries such as municipalities, drinking water and waste treatment, through mine exploration and reclamation, monitoring wells, stormwater, waste characterization, petroleum production and exploration, and with agencies from federal agencies to industry and manufacturing, all the way to individuals interested in their private well or garden soils, and working with clients all the way from Alaska to Mississippi. We provide sampling supplies and sample containers, preservatives, paperwork available for local pickup or shipped directly to your location. We provide convenient prepaid return shipping labels to get your samples back to us as effortlessly as possible. With 4 locations to serve you across Montana and Wyoming, give us a call today to set up your next project. More information can be found at energylab.com.
Well, I'm Eric Mears. I'm with Haley & Aldrich. I'm the market segment leader for our mining practice. I've been in the mining industry or working with the mining industry now for about 25 years. We work for construction materials clients, we work for industrial minerals clients, and we also work for hard rock clients, which are the base and precious metals. Well, the material at this site ends up in a lot of different places: roads and highways and infrastructure and houses and sidewalks and schools. Materials that are mined here are really the building blocks of our society. And without sand and gravel mining, you don't have the modern society that we have today. We look for solutions that fix kind of the bigger picture. We're not just out there putting a hammer on a nail head. We're out there saying, okay, who are the stakeholders? What are the issues involved? What are the kind of interchangeable pieces here? Things that make a difference when you're trying to build a solution that meets multiple needs. We have our core practitioners, the people that have had their boots on the ground on mining sites, have often worked in the mining industry. We've got one profit and loss center, which doesn't silo our resources and our people. We don't compete against each other to solve our clients' problems. We can take diverse experience in different industries and apply them to deliver some innovative solutions for our mining clients. We ask a lot of questions. We ask questions about, okay, what are the things that are immediately right in front of us? What do we need to fix right now? Who are the stakeholders involved? What are the other pieces of the puzzle? The idea is that we come to the table once we've done a lot of listening with solutions that really fit our clients' needs.
Everywhere we're operating, we're the largest private employer there. People are engaged with the mines and they take ownership of the mines. And as a result, the company is committed to the community.
Before we begin, we think of the end. During the operation, how do we minimize our impact and protect the environment? And then ultimately, how do we restore and reclaim that land to other productive uses?
We have a responsibility to our workers that they can stay safe. We have a responsibility to the communities that the workers will return home for dinner at night. We have a responsibility to our shareholders. We have a responsibility to governments that we will make a profit and we will pay taxes in order to support the general infrastructure. We invest in the communities.
It's that we operate in the best jurisdictions in the world, in Mexico, Canada, and the United States. And today that's more important in a precious metals company than almost anything else in the world.
The company that has the right culture, they're going to do it responsibly all over the world. And in the United States, though, you have the best environment to do it the best, right? You've got great laws, you've got great workforce, you have great minerals.
We have a plan, we have the team, we have the skill set, we've got the operators. And when you operate well in a community, it shows in the happiness of the workers and the happiness of the community.
Instead of saying, that's not my job, you say, what can I do to help?
So I'd rather it be done here where we can do it responsibly and you have a company like Heclo that does it that cares, because we need these resources.
I'm Phil Baker, CEO of Hecla Mining, and we're responsible,
safe,
Responsible, safe, and innovative.
Yes. All righty, welcome back. Thank you all for joining us at the 28th Annual Mine Design Operations and Closure Conference. We are back now after our first morning break, and our speaker this morning is Rebecca Oliver. Rebecca, or as she actually goes by Becky, is a principal engineer at Geosyntec Consultants. She joined Geosyntec in 2004 while completing her bachelor's degree in civil engineering at Northeastern University. Since then, Becky has gained over 15 years of experience in civil engineering, including technical contributions on a variety of geotechnical and environmental projects. Becky's mining-related experiences include tailings impoundment design, permitting and construction oversight, mine waste rock cover design, hydrologic evaluations, and stormwater management design and support infrastructure layout and design. Becky is a registered civil engineer in Alaska, Idaho, and California. So we'd like to welcome aboard Becky.
Thank you so much, Susie. Let me get my screen shared here. There we go. All right, let me know. Can you see it?
Yes, looks great.
Fantastic. Thank you so much.
Thank you.
So good morning, everybody. As Susie said, my name is Becky Oliver. I am a principal engineer with Geosyntec Consultants. So today I'll be discussing the elements which go into a site-specific drainage design for mine waste covers. As you can tell, this is a bit different than the topic listed in the agenda. So I apologize if anyone only joined for the evolution of a mine waste cover. My co-presenters were unavailable to join in August. So we decided to keep you on the edge of your seat for another year and save that presentation for the next Montana Tech Conference. So a little overview of what I will be talking about today. I'll introduce mine waste cover and purpose, the types of covers, why drainage is important, and then go over the high-level design inputs. I'll finish with conclusions, but spoiler alert, if you only have one takeaway from this presentation, it's that no one size fits all for drainage systems. Why do we have cover systems? Well, a few reasons. They contain materials that could impact the environment and prevent contact with those materials. In mining, that might include sulfide-rich minerals, which can generate acid mine drainage, and selenium leaching rock. They minimize liquid migration, so if you already have liquid in your waste, it minimizes the mobilization of that liquid. It minimizes water and air infiltration, the key to minimizing AMD and selenium leaching, and promotes surface water runoff and minimizes erosion. There are three main types of cover systems that you might encounter: a storm release, or otherwise known as a water balance or evapotranspirative ET cover, which generally consists of a thick layer or layers of soil which are specifically selected and engineered to store water during rainy or wet seasons and release water during hot, dry seasons. These act much like a sponge in that sense. Low permeability or compacted clay covers incorporate a clay layer to physically minimize infiltration of water into underlying waste. They are typically protected by thick layers of soil above to minimize damage due to desiccation and or freeze-thaw cycles. And last, geosynthetic covers. These typically incorporate a low permeability layer with a geomembrane. The geomembrane adds an extra layer of reduced permeability as well as protects the clay layer from desiccation. Notice I've not included a topsoil cover in this list, and while topsoil is used as a cover, it is excluded because it's typically not engineered or otherwise designed to have specific engineering properties. Of these three cover systems, the two we'll look at or consider in this discussion are the low permeability and geosynthetic covers. The reason why we are focusing on these is because of their incorporation of drainage layers. Diving into the two cover systems, there are three general layers above the waste material. There's the cover soil consisting of topsoil and other materials which may or may not have specific properties. The drainage layer, which collects water infiltrating through the cover soil. And the barrier layer, which could be clay only, clay in a geomembrane, or a geosynthetic clay liner with a geomembrane. Today, we are only focusing on the drainage layer. That's not to say the other two elements are not important, but they could be entire presentations or seminars all on their own. The drainage layer material may consist of aggregates such as rock or coarse sand, or a geosynthetic layer such as a geocomposite, geonet, drain liner, and or geotextile. Typically, the geotextile is used in conjunction with the drain liner or geonet, or as a component of the geocomposite, and is less common alone. In the rest of the presentation, I'm going to generally refer to the design of geocomposite as more common geosynthetic drainage material in this application. The general design considerations you want to think about with a drainage system include those listed here. Capacity. This is how much flow it can contain. Clogging. Make sure you design for potential clogging due to biological considerations, chemical precipitants, or ice blockages and freezing. The durability. In the case of a geosynthetic, the UV exposure of the geotextile and potential degradation resulting. The veneer stability, interface friction, and soil sloughing. In the worst case, stormwater and snowmelt conditions. We're primarily going to focus on the capacity today and how to design a system for the right capacity, accounting for worst case flow conditions to minimize veneer stability concerns, and account for reduction factors such as clogging. So why do we care about the drainage layer? Why am I talking about it today? Two main reasons. Poor drainage can lead to increased infiltration and cause slope instability. As illustrated, the collected water travels downslope, its head or depth increases. The increasing head increases the hydraulic gradient or driving force through the barrier layer, subsequently increasing the potential for AMD or selenium leaching. In the picture on the right, you can see evidence of a stability failure. If water cannot be adequately removed from the cover system, poor pressure buildup can lead to slope instability and subsequent veneer failures. Now that we understand the importance of drainage, how do we design for it? Rain and snow fall and collect on your topsoil, and a portion runs off. As the rain continues, or as the snowmelt continues, water starts to infiltrate or percolate through the cover. This is typically assumed to be unit gradient flow to account for rain on snow or snowmelt conditions. The drainage layer begins to fill, and water travels downslope with its depth or head rising as it continues downslope. As the water head increases, the driving force through the barrier layer increases, and saturation and potential destabilization of the cover soil begins. Based on the resulting impacts to the overall cover, the drainage system needs to be designed with fairly basic concepts: contain the flow in the drainage layer, minimize head as a driving force through the barrier layer, and do those two things by providing an outlet for the water in the drainage layer, which might be a bench or a pipe. Conceptually, there are three main components which can be adjusted to develop the site-specific drainage to achieve the basic goals. The first is the saturated hydraulic conductivity or transmissivity of the drainage layer, or how fast the water will move through the layer. This is material dependent, so it coincides with your selected aggregate or geosynthetic. The second is your thickness. This is a variable that the designer can control in the case of an aggregate, but is more fixed in the case of a geosynthetic, which come in different sizes such as 200, 250, 300 mil thicknesses. The third is your outlet spacing. This may be dependent on how you're building your dump and how the associated benches for global stability or simply constructability, or can be drainage design specific, such as this cover drainage or your stormwater system. So those of you who remember your Soils 101 course may recognize what these elements are, essentially Darcy's Law. Our Q will be the flow allowed in by our cover soil. Our K is the hydraulic conductivity or transmissivity as adjusted for the geocomposite of the drainage layer. Our I is the gradient of flow in the drainage layer, and our A is a function of our outlet spacing. Pretty simple concept, which of course we need to make appear more complicated, as I'll show. So now looking at some of the more technical slides, these equations are Darcy's Law restructured for our cover drainage purposes. The aggregate equation I provided is adapted for our slope inclination, our flow in and out, and the area broken out into length and thickness. The geocomposite equation I provided accounts for the transmissivity of the geocomposite rather than hydraulic conductivity, simply a function of the thickness of the geocomposite. The variables of the equation can be set with the remaining values solved for in order to develop your site-specific design approach. And we'll talk about that some more in the next few slides. Before I move on, however, there are two items that I do want to point out. The first is the cover hydraulic conductivity. The K cover, or the hydraulic conductivity of the cover, needs to be carefully considered. Soil generally degrades to 1 × 10⁻⁵ or 1 × 10⁻⁴ between those two values, centimeters per second. So regardless of your cover soil hydraulic conductivity at installation, design to a higher permeability is recommended. So that really starts to limit your flexibility with the KSAT of your cover soil. The second item is the required transmissivity versus the allowable transmissivity of your geocomposite. There are 6 factors of safety and reduction factors for the geocomposite for transmissivity, and I'll talk about those in the next slide. There's 6 reduction factors and factors of safety for geocomposite. Why so many? Because there is a lot less room for error in the design of a geocomposite. They're thin and slippery, and that is the technical term, slippery. So you want to make sure you aren't designing too close to optimum conditions. The overall drainage factor of safety is based on the overall importance of the drainage system for cover stability. The installation factor of safety is based on how difficult the construction conditions are and allowing for room for human error during construction. The long-term creep reduction factor accounts for the possibility of creep in the geonet or flattening of that geonet structure, which is typically a low reduction factor in the case of a cover system due to the low overburn stresses. Chemical clogging is typically low for cover systems unless you know you have possible precipitants from your minerals in your cover soil. Biological clogging is typically higher for cover systems, knowing you might see root intrusion into the layer. And geonet intrusion from the underlying and overlying geotextile may be low or high depending on the designer's best judgment. Typically, the closer your testing conditions in the lab are to your build-out conditions, the lower you can make this value. The takeaway from this is allowed transmissivity, or the minimum required by the material, may be up to 53 times higher than your required transmissivity, taking in the worst case of all these factors. Generally, covers are around 15 times higher, with biological clogging, overall drainage, and installation damage being the biggest factors with cover systems. And just to note, these are in the process of being updated based on new ISO standards. The ones that I have shown here are long-term standards by Kerner and issued by GSE, now Solmax. Diving into the factors of the equation, we'll talk about what affects hydraulic conductivity and transmissivity, or what sets these values in a design. First, your filter layer, or really your lack of filter layer. You want a filter layer to prevent the migration of fines into your drainage layer, which would ultimately reduce your hydraulic conductivity. Aggregate, specifically your particle size distribution, will impact your saturated hydraulic conductivity. Simply put, the more fines you have, the slower the flow in your drainage layer. A good, poorly graded, coarse aggregate will get you good flow. In the case of the geocomposite, your slope inclination will impact your transmissivity. Counterintuitively, the steeper your slope, the less transmissive your geocomposite may become. The structure of your geocomposite, biplanar or triplanar, will give you more or less transmissivity, with triplanars generally more transmissive than biplanars. And the reduction factors we just talked about. The greater the reduction factors used, the lower allowable transmissivity in design. The next design input, part of your Darcy's equation, is the thickness. You have significantly more flexibility with this in design incorporating aggregate than one involving geocomposite. What may set your aggregate thickness is either your maximum hydraulic head through your barrier, say you don't want more than 1 inch per year of water getting through your barrier, and back calculating what that driving head might be, or the factor of safety you might put on your thickness. We didn't talk about incorporating a factor of safety value in the aggregate equation before. It's not as established as geocomposites. Generally, a factor of safety for aggregate is set by a designer and the level of certainty they have in the remaining design features, but may vary from a little over 1 to 2 or more. Personally, I like factoring in the constructability element of the design, which may include installation of nothing less than 6 inches, but more likely a 1 foot minimum thickness for your drainage layer. Geosynthetics are much more straightforward in determination of your thickness. As I mentioned previously, it's set at the thickness of the material, which will generally vary between 200 mil up to 330 mil, maybe even as high as 350 mil. What sets your outlet spacing? For benches, it may be what the mine is already doing for constructability of the dumps and or global stability of the dumps. It may also be planned for stormwater control to minimize erosion. Ideally, you want to match up your cover drainage outlets with what's already planned so you don't end up with benches every 200 horizontal feet and one for drainage every 150 feet. For pipes, it'll be the size of the conveyance. Generally speaking, you're not going to want to put a massive pipe in your slope. So what can a 4, 6, maybe even 8-inch pipe convey at the slope anticipated? And then what can the down drains those pipes connect to convey? You can work your way backwards to understand what the drainage area can be managed by that size pipe and ultimately end up with your outlet spacing. So how do we put all this together? In these next 3 slides, I'll generally speak to when you have one of your input values set and how to adjust the other values to make your site-specific design that works. This first case is when you have a set hydraulic conductivity or transmissivity, such as an on-site aggregate you want to use, or a specific type of geosynthetic which may be readily available. As my illustration shows, at some point, your flow depth exceeds your material depth. So what do? You can add an outlet at your design depth, thickness reduced by a factor of safety, or you can thicken your drainage layer. These options are a little bit more limited for a geocomposite, pretty much being limited to changing your drainage layer outlet location. The second case you might have is a set thickness. This might be the case for a geocomposite. You have limited aggregate material, or you have a maximum head for your calculated percolation through your barrier layer. You have 2 options again. One is to set your outlet at your maximum allowable drainage head, again determined by your maximum percolation or driving force. The second option is to select an alternative drainage material with higher hydraulic conductivity or transmissivity. Thus, the water flows downslope quicker and doesn't allow for the head buildup of a slower material. Finally, the last scenario I'll touch on is when your outlet spacing is set. As I mentioned, this may be due to dumps construction, global stability, or stormwater controls. Keeping with our 3 variable theme, you'll look at adjusting the 2 remaining variables. You can increase the thickness of your drainage layer, or you can identify alternative materials with higher hydraulic conductivity or transmissivity. So quickly approaching my conclusions, I want to discuss just some best practices. The first, as I mentioned a couple of times, the unit gradient flow through the cover. Using unit gradient flow can seem like an overkill and sometimes can result in an infeasible geosynthetics design, but it is seen, and it may only be seen for 1 to a few days per year during snowmelt, but it is seen, and if you don't account for it in your design, you have the potential for a slope failure. Always use a filter layer. As I've said it throughout the presentation, if you don't have a filter layer, your cover soil will clog your drainage layer and result in reduced hydraulic conductivity and potential future failures. Keep your outlet spacing to less than 200 feet horizontally. This is really a design preference, but generally for global stability and stormwater, there will be benches at this distance. There are concerns with material, the impacts will be limited to 200-foot increments, and I've generally found that folks are uncomfortable going with much more than this. Consider constructability. As I said this previously, you might only need a 4-inch drain layer, but that might be extremely challenging to install on a 3-to-1 slope. Round up to the nearest 6 inches if you can, and if your material source allows. Consider stakeholder buy-in. And this really has to do with geosynthetics because they're seen as unnatural, and when reclaiming an area, unnatural is assumed to mean not long-lasting or performing. I've written a ton of white papers on durability and longevity of geosynthetics, but sometimes it just does not matter what stakeholders want, and they want a natural stone soil cover system. Consider that for the long haul permitting and buy-in. Sometimes it just makes sense to go with what the stakeholder wants and design around that. Quality control. This is absolutely critical for ensuring the materials you assumed in design are used in construction. That includes hydraulic conductivity and transmissivity testing with site-specific conditions, such as gradients. It includes checking your aggregate source regularly by doing sieve analysis for the aggregates, and evaluating the general properties testing for the geosynthetics to confirm that the materials you're getting are consistent and in line with your design assumptions. Then you want to monitor these materials during constructions. Oftentimes, when aggregates are placed, if you're nearing the bottom of your pile, fines can be picked up from underneath the pile and carried into the drainage layer. You want to minimize this as much as possible because, again, fines are going to slow that drainage layer. You want to make sure your thicknesses are achieved and verified with a survey or other method. And you want to make sure that when you place your geocomposite, it doesn't slip and subsequently damage an underlying geosynthetic. And you want to make sure that it's not damaged or torn. And if it is damaged or torn, that it is subsequently replaced. So lastly, again, if you only have one takeaway from this entire presentation, it's that cover drainage design is not one size fits all. You do not have to have the same design as another area of the mine, a neighboring mine, or something dictated in a textbook, unless of course your permit requires it. Your cover drainage does not and should not dictate how you mine. Your mine should dictate your cover drainage in the slopes, materials, and outlets. There are many, many more details to design that I've covered in this presentation, from additional discussions on unit gradient flow and cover soil saturated hydraulic conductivity, to filter material layer design to frost protection. To cover all of these elements would probably be a day-long short course. And with that, I will wrap it up if anybody has any questions.
Anyone have a question for Becky? Yes. Oh, several. Let's see. Great logical presentation with some use. Okay, that's not a question. Sorry. Are there upper conditions for selecting the hydraulic conductivity of the drainage layer, i.e., wouldn't you always seek to maximize KSAT?
You can. So a lot of times, and this is something that we found, your KSAT ends up being limited, or your measurement of KSAT ends up being limited by your equipment. So if you have a super high permeable material, you want to make sure that you do large diameter testing, which might only be at a specialized lab. But generally, you want to really pick a KSAT that's going to work for your system. So you could get a KSAT of, 1 times 10, 100 centimeters per second. But you might not need that. And in order to get that, you might have to screen your materials, or you can only use one type of material. So it might not be cost effective to get that highest hydraulic conductivity. So it's really all a balance.
And what storm return event do you design for?
That is the nice thing about doing unit gradient flow, because when you do unit gradient flow, it doesn't matter what your design storm event is. There's only so much.
Is there somebody out there that needs us? Oh, I'm sorry, Becky.
It's okay. And so the soil will only allow so much liquid through it. So it doesn't matter if you're in the 100-year storm event or the 10-year storm event. If your cover soil is saturated, it's only going to let water in so rapidly.
And any slope stability horror stories and what went wrong?
I'm trying to think. I should say not for me. Just kidding. But I hear of a lot of horror stories, and there's always lessons learned that folks travel around. But I've heard of stories of not including any drainage layer. Which if you don't have any slope, you'll end up with a soupy mess. But you might not need one. But yeah, I don't have any good ones to share, unfortunately.
Okay. Any more questions for Becky? Well, great. Thank you very much, Becky. Sorry I blurted in on you in the middle of your answer.
It's okay.
I forgot my microphone was on.